Okay, so for the main part, we had to do the collision layering. So in order to do that, I pretty much have every collision volume keeping track of its cheap center. So just the center, I guess, the center of any cheap volume we're using. So I also have to keep track of the additional stuff, which in this case for the sphere I need the radius, and for the ABB I just need the min and max point. And then for the ABB bounding box, for those variables, I pretty much just have the cheap center being the center, so just the position. The radius I have as being the scale magnitude times 5, because that's that pretty much encompasses the AABB. I wasn't sure if we were just supposed to be like scale X or scale Y, but to me that made sense because of it actually encompasses the thing, and it's a pretty nice fit for it. And then the cheap min and cheap max is pretty much just the same values as the bounding box because they're being computed anyway. It didn't make sense for me to have anything else pretty much because this isn't actually a loss in performance or anything. Same goes for the bounding sphere. It just copies its center and its radius. The min and max ABB is what we talked about in class, where you just get the position minus radius, position minus radius, position minus radius for X, Y, and Z. And then the OBB, for the scale, you only have to do it once, so it's the same thing as the ABB, just the magnitude times 0.5. So what would be the radius? And then for the cheap center, you have to keep updating it with the collision world. And then the cheap min and max is getting it from that sphere, so just the cheap center minus the radius, and then for all X, Y, Z, and the same for max, where you add the radius instead from the position. And then for the groups ABB, in the collidable group base, I added two vectors, one for the min and max, and an update call. And that update call pretty much just finds the first. Well, it basically sets group ABB min and max to the first one in the in their respective list, in the list, sorry, because it's one collidable group, and then it iterates through it. It constantly sets this group A min and max to a min vector or max vector, which just finds pretty much gives you back a vector with the min values that's shared between those two. So you get the group, the current one, and then the one we're going to check to see if it has any more min values. And at the end, you'll end up with the values for the group box. This function of updating is called on the collision test, because for me it made sense the only time you really want to update them is before you're doing the collision. The first thing it checks is pretty much if any of them are 0. If any of their sizes are 0, that just means that it's impossible to have any collisions because there's no pairs. Then we update. And this is testing for the ABB collision, where it gets the group. So this is pretty much checking the group versus the other group. If there's no collision, then just return. There's nothing else to do, which means don't call the callbacks. And then we get the first one of the group, and we test it with the other group. And if this one's ABB collides with the other one's group, just like group ABB, like we talked about, then it'll continue on. If not, then it just goes all the way through and does nothing pretty much. It doesn't call these callbacks. And then we do the sphere versus sphere. If it does collide with that, if this ABB collides with the other one's group ABB, then we check versus sphere and sphere. And if it does, then we do the actual collision test, which is right there. So that we have that layering. And just to show that it does work, I'm gonna open up a instance of it, and it's gonna show up the boxes when it actually collides. So just to show, so these yellow boxes show up when two collidable groups are colliding, and so that's why, because that guy over there. is making this box and then that box, so we're both colliding. That's why this is yellow. If you're inside of the other person's, if you're group 1 and if you're in group 2's collision, group ABB, then you get the purple ABB. So that's what that is. And then sphere testing happens right before the actual collision. So just to show that, it goes through the ABB. So there's the actual sphere, and then it's gonna check the actual collision, and then that's it. That's pretty much it. That's the layering. And then it also works for self, but in terms of the self collision, the single collision pair, it doesn't make sense to even use the groups because you're always going to collide with your own group. So pretty much it's just a layered one tier of sphere versus sphere collision before doing the actual OBB or whatever it is you're doing. And that's pretty much it. So this time for the demo, I was gonna showcase alarms and see if there was anything I could do to it, but it quickly became an input problem because before I had it, so I had to specify the key and then the type. But for me, it made sense that if I try to register for input, it implied that I meant both, or just for that key in general. So if I say register for input key 1, it would be up up and down, but unless specified. So what I did was I just put a default parameter that just says the key event type is being up and down, which is just which is used when you register for input or deregister. If you have that state up and down, then it'll deregister or register depending on the function for both of those key event types for that key. In addition to this, I also found that it was very tedious to have to deregister for every single thing I registered on termination, and that's because it's kind of usually most of the time when I was making games on this for demos, I wanted to deregister all of the key inputs, but I didn't have a function for that, so I pretty much created it. But in order for that to work, I had to keep track of my registered keys in order to, or for efficiency's sake, instead of having to search for the keys, I just keep track of it. And in the input manager, pretty much when you register or deregister, it'll add or remove that pair from the list. So that way, when it comes down to actually having to deregister all the inputs, all I have to do is look at that list and see if it's empty. So while it's not empty, I deregister, and the deregister already removes it from that list. So that's pretty much it. It just goes through the remaining ones after any other previous deregistration and just deregisters them. And just to show, I set 1 to being input. Sorry, I'll have to show this again. So I set 1 to being input, and then it stops after 2 seconds because of an alarm I just show myself. But I actually registered for multiple keys, but this one function gets rid of all of them. This was just to check for crashes and stuff. There's no crashes, so it's done. Okay, so this week I did a little bit of research for the sound on the individual project, just looking up, trying to get that flyweight in. And I found out that the sounds are actually buffered, and that's according to Nico, moderator of Erkland. This was a post on somebody trying to see if they could play a sound after it's been dropped. And because it's buffered, I think that means that I don't have to necessarily worry about the management, because iSounds are created and then they're okay, so when you create a sound, you pretty much just use the sound source. So when you play a sound, you use that sound source and it gives you back a sound if you enable like tracking or if it's looping. And before I thought that I couldn't get 2 individual iSounds from it, but it turns out I can't. Before, I guess I messed up something and it would crash, but now I have it so that I can use that sound source and create different sound files from it. And you can do different things like setting the volume and then all that. So basically, what does this mean? This means that now instead of copying my sound source and just putting an instance of it in the sound.h, so my sound wraparound class, I could just do it like we've been doing it in the game engine class, where I have like one kind of real copy, and then every other thing is just a reference to that copy, just like the textures and the graphics objects, not necessarily the graphics objects, the models. So basically, my sound class is a wraparound, but it also holds the parameters as if it was a flyweight. Um, like in this case, it's like volume, whether it's looping, if there's sound effects, and it creates a sound from that sound source, or it'll create I sound from that sound source, and then it'll apply all of the different parameters for like volume, etc. And then it'll add that sound source into an active list. And what's going to happen is that active list is going to hold all the references to the sounds in case that someone feels that they want to stop the sound in the middle of it or something, in which case they just call stop sound, and it'll probably reference the active list, find the corresponding sound, and then stop it. What else was I going to say? Oh, something very interesting I found out was Erkland has one event that's pretty handy in my case, and that's pretty much it has on-stop sound. So whenever a sound gets stopped, it'll call this function, and that's just a derived class from one of its classes, which is iStop sound receiver. I can set that sound to have that receiver, and then it'll call the function. And what I'm going to use this for is, like I said, if I put a sound out in the buffer and I decide to end it, then I can just end it, and then I'll remove it from the list. But if that sound has already finished, then I have to remove it from the list. So instead of having to check at every frame if the sound's already finished, I can just use this event to remove that active list. I'll have to do more research on whether that's like a flyweight or not, the whole buffering, how Erkland does it. But I haven't been able to do anything by looking at the code, just because I don't have access to the actual code. It's just kind of this. That's pretty much it.